Okay, this is a quiz problem that's modified from the fundamental problem 13-13 from the Hibbler textbook. After the modification, the problem actually becomes a little bit more difficult than the original problem. Let's see how we solve this problem. Eventually, we need to answer two questions, true or false. B is further away from the vertical shaft than A is. Let's say that's person A and this is person B. Okay, these two people have different weights, and they hang from this rotating structure with known rotational speed. The two cables are the same length, and the first statement is whether B is farther away from the vertical shaft than A is. Second question is whether the tension in B's cable is greater than the tension in A's cable. Let's draw the free body diagram for one of them. Let's use A. Okay, A is a little particle, and this particle has a gravitational force acting on it. Let's say mg, and there's also the tension, the pulling force from the cable. Let's call it T, and this force T forms a angle with the vertical direction of phi. Also, this particle has a centripetal acceleration, a sub n. Now, we are going to use the tangential normal direction coordinate system, except we introduce a third dimension z, which is necessary in this case. The tangential direction we actually cannot see because it's perpendicular to the screen coming out of the screen. So we are going to set up the kinetics equation in two directions, z and n. In the z direction, sigma fz is 0 because there's no acceleration in the z direction. The forces in this direction are the component of t in the vertical direction, cosine phi, and the gravitational force mg. The kinetics equation in the normal direction, the sigma force is equal to ma sub n, n being a sub n being the centripetal acceleration. The only force in that direction is the component of t in that direction, ma sub n. So now we have two equations, 1 and 2, and three unknowns, a sub n, phi, and t. So we need to introduce additional equations to take care of the extra unknown. We know we have the kinematics equation that we can use. The kinematics equation tells us a sub n should be equal to r times the angular speed squared, and the r is yet unknown. R is the distance from the center of the rotation to the person A. So it's R. Okay. So we have three equations now, but we have four unknowns. We just introduced the fourth unknown R. Now we can apply the geometric relationship between R and phi to form a fourth equation. The fourth equation would be this equation. This radius r should be equal to the cable length 8 meters times sine phi plus that distance 1.5 meters. Okay, we have four equations and four unknowns now. So we can solve these equations and get a unique set of solutions. In theory, we're not going to solve the equations in detail. We're just going to solve the equations to a degree that we can actually answer these questions. So solving, I'm not going to show the specific details. Solving the equations, we get tangent phi will be equal to 8 meter sine phi plus 1.5 meter that's the radius. This times angular speed theta over dot squared. That's the that is the angular centripetal acceleration, a sub n. And from the first two equations, we can get tangent phi is equal to a sub n divided by the gravitational acceleration g. Okay, so in this equation, we have only phi as the unknown, and one parameter is the angular speed, theta over dot, which tells us as long as we fix the angular speed, theta over dot, we have a unique solution for phi, even though we're not showing that solution explicitly. But we know there's a one-to-one relationship between phi and the theta over dot, which tells us as long as the rotation is constant, so these two people would have the same angular speed about the rotation axis, then the theta, this angle phi would be the same for both people, and because they're hanging from the same length cable, then their distance from the center of rotation would be the same, from the shaft would be the same. So this first statement, B is farther away from the vertical shaft than A is, this is a false statement. Both of them should have the same distance from the shaft of rotation. Okay, the second statement, tension, let's just use equation 1 to see what we get. From equation 1 we get T is equal to mg divided by cosine phi. Now because we know as long as the rotational speed is fixed, phi is fixed. So the greater the mass m, the greater the tension force T. Therefore, because B has a greater mass, so the tension in his cable should be greater than the tension in A's cable. So this is true. Alright, then we have carry out the analysis of the problem. We have been able to answer these two questions.